Question number 3, the solution of the equation log base 5 of 4 minus x equal to is. To solve these kind of issues, you note that you would have to equate both sides to the same log base. So you have to rewrite 2 as 5, basically 5 log of log base 5 of 2. And let me explain that. As we talked about last time, anytime that you have a number, you can feel free to write it as log base of something and repeat that same number. So this number 2 here is retained, and I can write log base 5 of 5 raised to the power of that same number. Likewise, you can write 3 as log x in the random number x power 3. As long as this is the same and this base is the same as this, the number that we use to raise to, then this is a good way to translate that. So now that both sides are based on log base of 5, so this number here, let me change the color of my pen. This number here then would be equal to this number. So therefore we have this equal to this. And this is, 5 raised to the power of 2, meaning 5 times 5, and that's 25. So now we start solving the problem. The principle of solving the problem is to do something so that you can turn it into x equals something. That means you're going to find a solution for x. And in this case, because I have a minus side over here, so I'm going to go and turn it into an x by adding plus exactly the same amount as this. Then both of these will cancel out. The left side remains a 4. The right side becomes 25 plus x. Okay. Now, I have a number 25 over here. I need to move it over here. So what I do is I add minus 25, and these two cancel out. And this left side becomes 4 minus 25, which is minus 21. Of course, as after you've done this solving problem the first few times, it will be coming natural to you that you would say, when you look at this number, you would say instantly in your mind that x will be coming over here, and it becomes a plus, and 25 over here, and it becomes a minus. So then x is equal to minus 21. Okay? So that would be, the solution would be this A. Question number 4, giving the function fx having a variation table such as this. The question is, what is the local maximum of that function? So they already have expressed that it will go down here, it go up here. So the local maximum is going to be this value. So the answer is 1. Let me explain that a little bit by talk to you about the concept of derivative. So given a function f of x, I can draw a line which is this line right here. The way that you calculate a derivative of this function is you pick a point x, the point of interest. You have a value that based on the y-axis called f of x. And then you add a small quantity in the direction I'm writing here. And so this value on the x-axis now become x plus dx. And dx is very small. Corresponding to the x plus dx, you have another value of the function called fx plus dx. The derivative, so first note that you can draw a line across these 2 points, and this line has a slope. A slope meaning how steep or how shallow it is with respect to the x-axis. And that slope is equal to the definition of this rise over this span. You've seen on the road, let's say this is a 5% grade. That means 5 over 100. All right. So the slope here is equal to the distance here, which is f of x plus dx minus f of x divided by the distance here, which is dx. So that's what I'm writing here. That is the slope of this particular line right here. So that, and the derivative is the definition that when you take the limit, this is limit LIM, limit of this, when you take the dx to a very small number, then this line here will become barely touching the curve. So now become this line. Okay, so that is the definition of the slope of the line that tangential to the f of x at the point of x. Tangent meaning it is touching such a way that it touches only one point. And what it means is, if that value is positive, meaning this end, let's say this end is higher than this end, meaning f of x will tend to go up as x moves to the right hand side. Fx go up. If it goes down, that means it is decreasing with x. If that line going down, and if it is flat like this with respect to the x-axis, that means f of x is level. Right, now let's go back and take a look at this one. So basically, here's the line that's the sign that's of f of x, which is the derivative of this function. So here they draw the line going down, which is this, and then it hits a minimum, and it hits a maximum, and then it goes down to infinity again. So that's what we said. It's the local maximum.